Hi, in these sets of tutorials we are working with accelerometers, and in this video we are going to get accelerometer data through the serial port into Supercollider. Okay, and I've done a number of these before, so go ahead and work at your own pace, skip through if you need. The first thing I'm going to do is just look to see that my device is there. So I have my Arduino plugged in. If none of this makes sense to you, then go ahead and follow a few of the previous videos. But I have my Arduino plugged in, my accelerometer connected to my Arduino, and now I just want to get data from that accelerometer through the serial port into Supercollider. So I'm going to look and just make sure I have the right device. So I'm going to go serial port dot list devices there. Okay, and I'll go ahead and evaluate that, and I see that I have these devices here. I see that I have those devices there. Oh yeah, and also you're going to need the Arduino library or the Arduino Quark installed into Supercollider. So if this isn't working for you, then you probably don't have that Quark installed. But I have a video also that shows you how to do that. Okay, so I copied that little bit of information because then I'm going to initialize my device. I'm going to create a variable. I'll just call Eno, and I'm going to have it equal to serial. Arduino. Again, this is another library, SMS, and it's looking for the port name, which is that in quotes. Okay, and then the baud rate, well, we use the 38400. Oops, 400 in our original Arduino code. Okay, and then you want to make sure if you're just doing this straight after hooking up your Arduino, you want to make sure your Arduino, the serial port is closed. The serial monitor is closed, because that will prevent you from doing this. And generally, I just close up Arduino anyways, because the code has been uploaded onto your board. Okay, so if I evaluate that, it says an Arduino SMS. That essentially means it works. All right. Now, what you noticed when we were doing in the previous video, when we were doing the serial monitor, when we got to the point where we're looking for data, it said send us any character. All right, so we're going to go ahead and, since we started that, we'll go ahead and send it a character. So we'll go eno dot send, and then I just got to get the syntax here. I believe the characters preceded by $sign. Okay, so to get it, make it a $sign. We're going to send it just any character, A. In this case, we've sent it. Now, it should have initialized. We don't see any of it yet, but it should have initialized. It should be initialized. We'll make a note. Um, 6050 library. Okay, and then we'll have an action now. Let's just take our time and build this up step by step. So we'll say ino.action, and this will be equal to a function, some kind of function. Okay, and then in that function, we'll make our first argument there, msg, the message. All right, and then we'll just print out that message. Give a little space so you can see what we're doing. And we'll just simply print out the message, msg.postln. Okay, so once I evaluate that action, I should be able to get my data in. So there it is. It's all the kind of jumble of data coming in. Okay. Now we'll just leave that go. It's fine. We'll let that run, and we'll expand this. So this is kind of like step one. So I'm just going to copy that here. So so you can see, step by step. We'll go ahead and do that. Now we're going to expand our action. Let me break it out a little bit here. So we have that argument message just coming in, and that's what's being posted. But we're going to parse that by the header. So what we're going to say is we're going to create a variable here, var, and we're going to say var message split. Okay, because we're going to split that message by the colon. Okay, so we can separate the header from the data. Now, again, we've done this before, so again, work at your own pace. If you need to skip through this, great. Then we're going to say message split equals, and let me just remind myself of the syntax, split, okay, and then what, and then by what, okay? So we're going to use the function split, And then what are we splitting? We're going to split MSG, okay, which is a string, so it splits a string, right? It's coming in from the serial bus as a string, all right, and it says something something with a colon and then a value. So we're going to split the message, and we're going to split it by the colon. And again, same syntax, use that $sign to designate a symbol that you're going to split by. And that means, but it removes that colon. So now we're going to get an array, and without the colon because it's using that to split. And the first slot 0 of the array will be the header, or ACC X, Y, or Z. And that was hard coded into our Arduino code. And then the slot number 1 will be, or the right side of the colon will be the value. Okay, so we can actually just now go and say MSG split dot post ln. Okay, just so you can see how that looks. Now if I evaluate that, that's just going to replace the previous action. So I'll go ahead and do that. And you notice now it's the array. And the colon's gone. We have ACC X, Y, Z, and then we have the values that are and that's really handy now because we can have, we can sort by the header, and we can get the value of each individual X, Y, or Z. Okay, so that was part. This is V1. Okay, and then this is V2. All right, and let's go ahead and comment that out as well. Oops, right, of course, because that's actually commented out. All right, now I'm going to copy that here. Copy this much. And start with we'll call V3. Okay, now now that we have this array, which is message split, it's an array. Okay, we can now sort by the header. So we're going to create 2 more variables, var, and we'll call the header will equal to message split 0, right? The header will be in the 0th thing of this array, right? The first slot. And then var val will be equal to MSG split 1. Okay. Now let's go ahead and make sure these are aligned. We're going to see as string. Though I already mentioned that it's going to be a string here. I don't know. That's probably redundant. It's probably too far. And then this will be as float. And we just presume that all the values are coming in as floats. Okay. So now we have our vars, our headers split out, and our vals split out. And that's just simply by referring to one member of the array. And now what I'll do is I'll just do a sort. Okay. So I have a couple of choices. I can do a switch, or I can do an if statement. All right. So why don't I do a simple switch then? I think that will. So I'll make a little comment there. We'll say sort by header. Okay. And we'll say switch. Okay. And I believe the syntax here is what you're switching by. So we're going to switch by the header, and that's a string. Okay. And then you put whatever it is. Oh, you know what, though? I'm sorry. I'm going to go back and revise a little bit. I think sometimes it's a little bit handier when you use symbols, just because it makes, at least from the Smalltalk Supercollider side, it makes things a little bit easier to do. Okay, so we're going to do as symbol. All right. So we're going to change that string, which was a string before. We're going to change that into a symbol. That's basically the header is going to be a symbol. It just makes it a little bit handier, I guess, to sort through these things. Okay. So back to the switch. What we'll do is we'll have the symbol, which is ACCX. Oops. Used the wrong. I said it was simpler, but I used the wrong thing. ACCX. Okay. And that's going to be what it's looking for in this switch, right? And then once it finds ACCX, it'll do it'll perform that function. Okay, and then we have ACCY, and then whatever there, and then we have ACCZ. Okay, and then it performs whatever function you want it to do there. All right, and then you can just simply finish your switch off with a semicolon there. All right. So let's go ahead and in this one we won't post anything else, but we'll just post the uh, ACCX. So that's basically the switch is looking saying if the header is equal to ACCX, and we've already converted to a symbol, then go ahead and run that function. And in this case, we'll just post the value. So we'll say val dot post ln. So that's this value, but that'll only be the value attached to that particular header. Okay, hope that makes sense to you. Let's go ahead and run version 3. And so now we have just the accelerometer X, and I'm tilting it to the right, down to the right, down to the left. So basically you got a kind of 90 degrees. So when it's perpendicular there, I'm going to have to the left perpendicular. I'm going to have, well, it got to 82. So, well, it's just giving me about 82. And then when I have it just straight, it should be close to 0. Yeah, anyway, it's pretty close. And then all the way to the right, oh, it's giving me a little more. Oh, it's going to go pretty close to 90 there, 87. Okay, but it's basically 90 to 90. That's what you get from accelerometer X. Okay, great. So we have that. And so now we can use this value in here. So that's quite handy. So let's go ahead and make a version 4 then. We're actually using the value. V4, okay? And I'll copy that all. And of course, you can do the same thing with all the rest of your accelerometer components. You can do AZZY or AZZZ and do something different with each one of those. All right. Now, I'm wondering if I should just end this video here. Yeah, no, let's continue on. Okay, so now what I'm going to do is, what I want to do with this, instead of just getting the raw value all the time, basically I want to do, I just want to, choice, I can use this raw value coming in and just map it if I wanted to go, say, from, say, whatever it is, 82 to negative 82. I can just have maybe map that to absolute pitch or something like that. And so I can have to the right, be, pitch high, and to the left be pitch low. And you notice it's kind of inverted there. I mean, I suppose one thing I can do is just simply turn around my, 180 degrees, which I've done here, my accelerometer. Now if I go to the left, it's negative. If I go to the right, it's positive. Whichever works, or you can switch around the mapping. So we can do that. So basically, I want to map this and then send it to a control bus. So let's do the version, and this is worth some kind of additional information. We're going to just take map p raw values, raw ACCL values. So it's just the stream coming in. I'm just taking it as it is. So this is one way of using it. Okay. So yeah, I already have that. So what I'll do is I will map it. I will take val, and I will map it using the function linlin. Okay. And it's going to go, original to, so it's going to go from negative, what did we say, negative about 82.0. And it's going to go to positive, say it was about 87.0, okay? And we're just going to map that, say, we'll use MIDI notes, and I'll create a quick synth-def to map that to some kind of MIDI note, all right? So let's start, say, about 40, okay, and then we'll go to about, say, 70. And those are MIDI notes. 60 is middle C, right? So that'll be whatever, pretty low to pretty high. Okay, so, and then what we'll do is, why don't we make that something? So let's break this out a little bit. So this is still all this one function, okay? And we'll make this something. We'll call it a variable. We'll call it var. We'll call it VMP, value mapped, okay? Something like that. I forgot my parentheses there. All right, so the VMP will be this value, which is the raw value coming in, but it'll be mapped to something we can use, say 40 to 70. All right, And then we'll go ahead and just set a control bus. So what we need to do is we need to create a control bus. I'll do that way up here as part of my initialization sequence. I'll just call it, for example, tilde KB equals, and I'll create a few control buses here. I guess we need 3 of them, so we'll say bus. And remember to use that exclamation point multiplier to create an array. You need to make it into a function, so we'll say bus dot control, and then it's going to be s. Excuse me. Oops. And then it's the function within a function. Then we're going to multiply that. Well, we have 3 streams of data, so we'll just do it by 3 for now. I think there might be reasons to do other things. Since I have everything running, I'm going to go ahead and evaluate that line. So now I have 3 control buses, KB0, KB1, and KB2. Okay, and so here, going back to my switch here, accelerometer X, the mapped value there is just going to go into that control bus. So I'll do KB0, we'll just put the X in the 0, dot set. And then what we'll set it to, we'll set it to the VMP. Okay. I'm pretty sure that's how it's done. Isn't that the syntax? Yes, that's set. Okay. There we go. So now control bus 0 will be set to that value, which is mapped between 40 and 70. Okay. Let me go ahead and there's no post, so that's good. So I'll go ahead and evaluate that. And then we'll set up the rest, just a quick tester for that. So the printing stopped because there's no post. And let me just quickly make a very quick synth and I'll just leave this in here. We'll say ACC test. And then, oops. And then let's have an argument. We'll have pitch. And we'll say default equal to 60. And we'll have a var. Sorry, no, we're going to have a pitch determined by the. Oh no, that's right. Yeah, arc pitch, and then we'll have a var. We'll have sig, if you want, if you wish, equals to sine OSC, which is make a sine wave dot AR, and its freq will be the pitch, and then dot MIDI CPS. We're going to convert that MIDI note into a cycles per second to hertz. Okay, and that's fine. And then we'll just out dot AR, we'll just send it out to 0, and it'll be the sig. Okay, and that's a quick and dirty one, so we'll go ahead and do that. Evaluate that, save that, and then make an A equals synth. I'll just turn this down a little bit because it's going to be loud. Synth, and it'll be ACC test. Okay, and then just go ahead and evaluate that. Oh, I didn't boot my server, so let me go ahead and boot. And then send that again, and then start up the thing. Okay, so we have that. I'll go ahead and mute that out. And then, since this is being mapped and being sent, we can go ahead and map go a.map, map the argument to that control bus. Okay, and if this is too fast for you, or you don't know what the heck is going on, hopefully they're named correctly. I've put out several videos that goes through this a little bit more slowly and in detail about what mapping is and how to use control buses. Basically, it's kind of like a patch bay. You might think of audio, but you could use control signals this way. So we're sending a control signal to just a private bus, and then we're mapping. Then we can map arguments to those buses. Okay. So in this case, the pitch will be controlled by whatever's coming into that bus, the data that's coming into that bus. So we'll go ahead and map. We have to tell it what to map, what argument to map. See, we're using the asynth. We're mapping the asynth, and we're mapping pitch, and what we're going to match pitch to, which bus we're going to map it to, which is going to be that KB control bus, and it'll be 0. Okay, so that's going to go ahead and be mapped. The pitch is going to be mapped there. So if I evaluate that, and then I bring my sound back up, and I'm tilting my to the right and then tilting to the left. So already you can imagine, kind of a theremin-like instrument. Okay, and you can let your imagination run wild, and obviously create a much different synth there, and you can already use that. Okay, so that is the one version of that. So I'll go ahead and save that. That is the one version of that. I'm going to go ahead and recompile here, just so I can start this over here. So that's the one version of that will work, and I think that works pretty good. Let me just copy all of that. We're going to do a version 5 now. And the version 5 is now a slightly different approach. It's going to be allow us to just change the value gradually using the accelerometer instead of the absolute location of the accelerometer, the x-axis, for example, being corresponding to a single, a pitch thing. We can shift it to the right and make it go up, and then shift it to the left and make it go down. Okay, continuously. Okay, so that's I don't even know what to call it, but we'll call it version 5, and we'll call it whatever, incremental or something like that, incremental shift. I have no idea. That sounds very, very intelligent though, so we'll just leave that. Okay, so basically the idea is that now we're going to have a separate value. So why don't we go up into our initialization area, and we'll just create another variable. This will just be a holder. Okay, just a variable holder. We'll just call it ACCX ACCXV, maybe for val. Okay, or just call it XV. Okay, and then we'll just make it equal to 0.0 for now, whatever the case might be. Oh no, you know what? If we're doing pitch, then let's make it equal to 60. You can make it whatever you want, 60. Okay. Now, if we go down here, I should evaluate that. I guess you don't really need to have it initialized, but sometimes that's good practice. So now what we'll change this is we'll basically have it increase by a certain amount. Okay, so we're going to have this now be the amount it increases, this VMP. All right, so these still stay. This mapping still stays because it is going from -80 to 80. All right, but now we're going to make it very slight here because the data is coming in really quickly. So every time a new piece of data comes in, this is going to add or subtract this amount, and it'll become more clear when we actually get to it. Okay, so this will be, say, 1 is too much, but I'll say negative 0.1. Let's see what negative 0.1. I think that's still too much too, and then 0.1. These are a bit abstract, a bit arbitrary, and you just kind of can adjust. Okay, so basically, as I tilt it, it'll go from -1 to positive 0.1. If I'm right in the middle, it'll be 0, and everything in between. Okay, and in this case, what we'll do is we'll keep that setting the control bus because we're going to still set it. But before we do that, we're going to take that. What did we call it? We call it XV, kind of the X value, and it's going to be equal to itself. We're just going to increment it. Okay, so it's going to be XV itself plus the VMP plus this little bit of addition. So this is controlling how much we add or subtract from this XV. So if it starts at 60, it's going to add, if we're at the maximum, every frame, which is pretty quick again. And you can slow that down in your Arduino by changing the delay. But I won't get into that right now. Stay focused. So it'll change it by every time it comes in by another 0.1 the MIDI pitch. So it'll keep going down. Okay. And basically, you can constrain it too. That's always a good idea because otherwise it'll go down to negative pitch, and it'll go up way too high very quickly. So why don't we go ahead and constrain this value xv? We can either do it on another line or we can constrain it on here. So why don't we go like that? I forgot how I do it, and it's counterintuitive because there must be a better way to do this, but there's a max min. Okay, max meaning dot max, meaning take the it's the lower end. So take the least of the two. Which one is bigger, and keep it, whichever is bigger. Okay, but it actually means the lower end. Anyways, you'll see. So if we want it to go, if we want it to go below say 40 MIDI pitch. Okay, so it's going to be maximum 40, and then we did do dot min. Again, it's reverse. It's counterintuitive. Let's not go any higher than say 70 again. We can go 80. Oh, sorry. We can go 80 if you want. Go a little higher. Okay. So then that's going to be constrained to not going lower than 40 and not going higher than 80. Okay, but it's going to add every time a little bit. Okay, and then we can adjust these as we go. And then this, instead of setting the VMP, which is just the increment that we're changing it by, we're going to go XV. And maybe I should have my camera. Well, it's fine. Right. Okay. So now, since I've recompiled, I have to redo everything. So I'm going to go ahead and boot my server. I'm going to start my Arduino. I'm going to send it that little character. You have to wait a little while. It takes like a few seconds, so that's probably enough time. Send it A, hopefully get started. We'll start these control buses. We'll initialize that variable, and then we'll send the action here. Oh, might as well, okay, we'll send the actions here first. Okay, so now that is coming in, it should be changing just a little bit. I guess maybe let me just print that. So we'll just post. We'll do xv.post. xv.post. Okay, and then I'll resend that. Just the action. Okay, so now you see it's 62, and I'm just holding it kind of level. And then if I shift it to the right a little bit, it should be growing 64, 65, but then back to level. See, it's just holding, and then slightly to the left, it's going down, but back to level, then it's going down, back to level, going back up. And so now it's perpendicular, so that's the fastest I can make it go up. But see, it stops at 80. See, I've constrained it. And then now perpendicular the other way, and that's as fast as it go down. So actually, we can probably make that go a little bit quicker, and then just do, slight changes making a little bit of difference. And you can see whichever works for you. So we'll make that maybe 0.2, which is double. It seems like a little bit, but it's double that. But we'll give it a go. Let's see what happens there. Okay, so I'll go ahead and evaluate that. I'll leave the post in there, and then I'll evaluate my synth def, and then I will start the synth, and then I'll map it to that. So there you go. See, I can shift a little bit and then hold it. And you can use that max min to constrain kind of like, you can have a better margin. What I mean to say is like the level, so I don't have to hold it perfectly level to keep it from moving, changing. I can manipulate the data a little bit so that I can have a little margin of error there in my holding it. It's not changing. Say only change if it's greater than so much. Okay, so then there you go. So that's the other version of that. The other version of that now. Version 5 we got to, so you can do kind of an incremental shifting now. You can do an additive bit, or just adding a little bit every time And then this original thing is just taking the raw value, so your absolute position, which is nice too, So if you're all the way perpendicular, it'll always be whatever it is, the 70 or 80, whatever note that is. Okay, and obviously you can use this in a lot of different ways. So that's a pretty comprehensive look at just how to get the data in. And then in the next few sets of videos, I'll actually be doing something particular project, I think, which might be a little bit interesting. Try to create something that that's a little bit more well developed. Okay, but the actual next video, I think we'll go ahead and clean this stuff up and create some variables there. Okay, so well, let's go ahead and do this. I might split these up anyways. So right. Okay. So then we have this kind of incremental shifting. We have the raw values. I'm going to go ahead and stick with this incremental shifting model right now, and you can choose which one. It'll be the same however you do it. Okay. And the first thing I'm going to do now is to make these kind of variables that I can change. All right. Oops. Make these variables that I can kind of adjust more on the fly, and that's easy enough to do. So I'll just like I did up here, I'll create some variables, and then I can kind of change those on the fly to make it, so while I'm playing, I can make changes there. So let's create some global variables there. We'll say inc. We'll call the increment min. Okay, and we said equals to negative. Actually, we can say inc. Okay, and then we can just have a positive and a negative version equals to 0.2. Okay, that's the amount we're going to change it by, right? Okay, and then we're going to go back down here to this action here, and we'll just say this will be the negative inc. Now, I've been having problems, and I'm sure someone can help me, just leave some comments or something like that, having problems with the negative sign. So I think the safest way really is to be super kind of like use kind of weird language and say the inc, okay, and then we'll just multiply that by -1. And of course you need a space between the negative. Okay, we'll say that this will be the inc multiplied by -1, sorry, and then the whole thing in parentheses. Okay, so that'll be the negative version, and then this will be the positive version, will just be inc. Okay, oops, with a tilde. Okay, so hopefully that was understandable. And I mean, we can make these variables too, but these are unlikely to change. In fact, they're kind of hardwired in the thing, and I've looked at them. It's really -90 to 90, but I'm just getting, I guess that's the response it's giving me. Okay, and then we can do the constraint to here. So we can have, let's create a variable. We'll just do it here, and then we'll put it up top. We'll call it x min, okay, and then x max. Oops. Okay, so then it'll be x min and x max, and then you can change those on the fly too, in case you're not doing MIDI data, you're doing something else, and obviously you can change the amount it changes by the inc. All right, so here we're going to have x min and x max. X min is equal to, we'll just do like 38, and x max equal to whatever it was, 80. Okay, so then that'll be the MIDI note number. That'll change that, and that still updates here, which is fine. The x value is just a kind of a placeholder to move it into this control bus, and then we can get rid of this post if we want. Okay, so that makes a little bit, a little bit easier, so we can do this in real time. And just the last thing I'll do here is, well, two things I'll do to just kind of make this code really kind of the way I want it, is to now have all three axes. Okay, so we'll go ahead and say replicate then all these. We need, so I guess we have to change this to x inc. And let's go ahead and make sure we update here x inc. Okay, so this is just a little bit of copying and pasting. You can fast forward ahead, but basically, we're going to take all those, copy, and make sure we have one for y and one for z. XV, so the y value, the y increment, the y min, and y max. And you can decide, what, and then the z, what things are changing with each one. The z increment, the z min, and the z max. There we are. Okay. And then we'll just copy this code in here and add it to the y and the z there. Okay. And then we'll have to just update each of those. Now, I have a feeling these vars aren't allowed this way, but I forget. But I think just in case, maybe we just make these slightly different, which is VMP2 and VMP3, something like that. Okay. And then the val's okay because that's universal for everything. And these values should be okay. I think Z is slightly different. I think it goes 0 to 180. So we'll look at that later. Okay, just make sure we update all the y's. So these are the y's. Y is the same. It's fine. Y value, y, and then we call this VMP2. Okay, that's the mapped one. Then y min, and then y max. And then KB1, because it'll be setting, we'll use that control bus, the second one, and then this is YV. Okay, and then the Z, let's go ahead actually and let me map these out. Let me comment these out for now, just so we can actually see what the Z gets us, and then we'll say val. Okay, and then if we go ahead and evaluate all that. Oops. Okay, oops, it's not working. Because why? Oh, because I think I stopped everything, did I? What did I do? Oops, because I deleted everything. That's weird. Okay, sorry, here we go. And then here. Control return. There we go. Right. Okay. It's not giving me a val. Okay. Sorry. Go. So actually, I'm twisting it kind of like a dial, but keeping it parallel. So I guess I'm going to about, yeah, like I said, I think it's about 180. We'll say 180, and then if I twist it all the way, so then 150, 60, 70, 80, 180 about there. It's kind of an odd 180. It's not quite 180 to me. It's kind of like like 15 degrees. And if I twist it around that way, it's gone to 0 about there. So it's 0 to 180, and you can kind of recalibrate it. So if I'm holding it straight up, I'm going to that's like that 150, and to the right, it's going to about negative something like that. But I think there's actually some calibration things in the actual Arduino code itself. We won't get into that, but if you look at the code, there's a section there that says change these numbers to calibrate it. Okay, so in any case, our mapping, assuming we have the calibration correct and everything like that, our mapping really will be from let's see, from 0 to 180, right? I want to turn it. Oh, now it's. Oh, I see. Let's see, 0 to 180. Well, still it's kind of off, but I won't worry about that too much. Yeah, so 0 to 180. I filled the wire, so now it's broken. So we'll just go 0 here. We're going to map from 0.0 to 180. 180.0. And that'll more or less get us there. And then, we can change the min and the max there however you want. Okay. All right, so that should be, and we'll get rid of this val here. That should be us there. So now you have 3. Oh, of course, I'm sorry. We have to go through and change all these things. So this VMP3, this is going to be Z, and Z Inc, and then ZV, ZV, and then Z min, Z max, and then KB2, and then ZV. And don't forget to change this to VMP3. Yeah, because I think in switch the variables carry over, so you just be replacing them. All right. Okay, so I think that's pretty hardy code there. I think that's going to work for us for a number of different things, to using the accelerometer within Supercollider. And then, like I said, I'll be hopefully working on kind of a little bit more, a little bit more significant project using this code. But this gives you an idea for your own uses, how to get the accelerometer data in, and then how to map it and use it, either as kind of a raw thing, so then its absolute position will correspond to an absolute data, or to use it as kind of a lever, a kind of to push it a little bit lower, to push it a little bit higher, the values that way. And that's how I'm going to choose to use it, hopefully in a project. Okay, so good luck with that. Hopefully that works for you, and you can have some fun with that.